what I'm going to talk about is some of the things that I do for DuPont and in the travels and within industry that we do. It's basically about us using ultrasonic leak detection, not just for compressed gas surveys or steam traps, but for a wide variety of things that we do within the company. That's my mug shot. We changed it 3 times before people could find out what it really was. I want to put a number across the front, which would have kind of enhanced it. The first one was at coveralls, and it really would have looked like I'd have been a criminal there. But I'm out of the Pontchartrain site in Laplace, Louisiana, in case anybody don't understand my accent. We used to have interpreters for this, but you know, we're going to try the best we could with this. I've been with the company going on 33 years. My areas of expertise, as you can see here, is compressed gas systems. We work on energy standards, you know, fundamentals of energy. Main thing I want to say is like in 2005 was the first time when I got certified level 1 ultrasonics with Drew. And Drew and I was in the back kind of talking, reminiscing about that. But that's something that, you know, within my 32 years experience with the company, it's really amazing of how far we progressed with these types of technology and all. My main areas of expertise is steam trap inspections and compressed gas leak surveys. What we'll do during this presentation is we kind of go through our process of the surveys and what we do for the plant sites and what kind of product that I offer as a surveyor going forward. Here are some of the businesses. DuPont is a science company. We're kind of changing our portfolio of things we do. There's 7 primary businesses. I'm glad that it's big enough for y'all could see, because my little handout here is you need a magnifying glass to see it. But we do have agricultural business, electronics, industrial biosciences, nutrition and health, performance chemicals, performance materials, and safety and protection. The group I'm with is the safety and protection group. We manufacture Kevlar for a bunch of different industries, and mainly our law enforcement and military. The sites, we have a diverse business located worldwide. Many of the surveys at the plants that I have done are basically within the U.S. I've done some for Canada, and I've actually been to Puerto Rico, been to Luxembourg with the help of Roy there. Big help, thank you, appreciate that. And I actually have done some surveys and some consulting for some of our customers. So, you know, not only do we do just DuPont sites, but we try to help out our customers to help them reduce their energy costs and to improve their uptime. About the technology that we use, you know, ultrasonic leak detection, technology that identifies defects that can negatively impact our progress through compressed gas systems and steam systems, which basically is the 2 main ones that I look at. I've also done vacuum, hydraulics, and mechanical inspections as far as bearings, which we heard about in the previous presentation, how they use infrared. I also use infrared technology, you know, as far as the bearings and valves and things like that. Technology is quite versatile and has been useful in assessing and troubleshooting a lot of variety of mechanical issues. DuPont has a lot of detectors that we use within the company. Basically, it's the majority of them are from UE systems. The 2 that we use the most are the UP2000 and the UP9000. After been at the plant a day or 2, you know, and showing the people what I do and what things we're trying to find, they're really amazed at, you know, the stuff that we find out in the fields by just walking around with one single piece of equipment. A lot of them will tell us that they have to go back to the shop 2 or 3 times to get several other pieces of equipment to try to find the things that we do with just the ultrasonics. You know, just by changing a probe on the same handheld that you have, you know, it's really amazing. Main thing is, you know, we want to make sure that people are properly trained at what we do. And biggest thing of all is common sense. You know, Senator earlier talked about, you know, how many degrees you have. You know, I mean, it's, you know, some people, you know, I hate to say it, come out the wrong way, but it's that they're so smart that they're missing things and stuff like that, you know. I mean, I'm grassroots level, you know, started from the bottom and then try to work the way up and all of that, but the main thing is being properly trained by the proper, people that actually is experts with the equipment, and using common sense. I mean, if you make sure you train and use your common sense, you'll be able to solve just about 90% of the problems that you face every day. We feel that it's a great technology that we put in the toolbox. The virtual toolboxes, when we have our meetings in the morning, the guys know that they can go back if they find an issue or something and pick up this piece of equipment and go out and start troubleshooting. I gotta watch my notes. I gotta make sure I don't miss nothing. So, just some of the ultrasonic leak survey. The general purpose of what we do is, we try to help the plants identify the defects that will negatively impact the use and cost of energy. However, we look at items, relating to energy associated with the steam systems, safety and sustainability. The main thing, and you heard that earlier this morning, safety is the #1 priority at the plant sites. We don't want to do any shortcuts or anything to get around just to make sure we can get something working or keep it working. Safety is the main issue. If, we can be the highest production rate plant in the company, but if we're hurting people doing it, people is just going to shy away from that. We have to make sure that we can make the product, make it on time, and make it safely. Finally, we attempt to put into place a sense of awareness and knowledge and the tools necessary, for, am I on the right page? Yeah. The tools necessary for the sites to achieve the benefits and situation, sustain the best practices. I try to do my best, like when I finish the survey, to hand over a completed survey with the items and defects on it that we can prioritize by cost, by production rate, by safety, any type of issues that we have. And then that way, when I leave the plant, they have everything they need to make sure that the job can be completed. And we do this by, again, training, best practices, and basically this is what I do. I'm on the road just about every other week, going to different DuPont sites, doing surveys, doing training, and we'll talk about that a little bit later on as far as the training part of it. But again, getting the training from reputable sources like UE Systems, and the infrared folks and then the steam trap folks is the main objective. And we just don't want to give somebody a piece of equipment and say, here, figure it out, go use it, come back with a good survey. I mean, we're not going to get those results like that. So we have to make sure that everybody's properly trained. The survey process, or the compressed gases, it's a survey that include the following utilities. Compressed air. A lot of people talk about compressed air. Basically what we call it, some people call it wet air. I refer to it as plant air or instrument air. We associate breathing air with it. Other different type of compressed gases that we survey would be nitrogen, natural gas. Some sites have oxygen, argon. Any type of gas that can be compressed, we basically just call it compressed gases, but anything out there, we try to identify the leaks and document. That way we can go ahead and provide a good beginning for some maintenance and reliability. The air systems are most common and extensive. There's various types of compressors that we use within our compressed gas, and this is eye chart #1, so I don't know if y'all be able to see most of that. You can kind of make out the pictures of the air compressor here. 3 types of compressors we use within DuPont: centrifugal, screw, and reciprocating. Basically, our main compressors that we use are centrifugal compressors. Then from that point, we go to the intercoolers and aftercoolers, and we push in the air through receivers, then dryers, and then all the piping and associated applications and users for this. One thing that a lot of people at the plant sites, because mostly I deal with operators and mechanics when we go through with surveys and all, and they think that compressed air is free, and then when we finish with the training and they realize how much money is being wasted, and they actually see that dollar amount, they realize from there, it's like, wait a minute, we are actually losing a lot of money. So we have to remember that compressed gas is not free. It's the most expensive utility within DuPont, and probably with most of the plant sites and in industry that we see around. And It can be a significant investment for compressors and drying, because if you don't have dry air going to the end users, and then they're going to start shutting down because you can't get the proper pressure. And we have to think of, we're talking about a product out the back door for making money and things like that. But as a utility, I'm a power person for 25 years, been in the power area and all, and nobody really thought of us as producing a final product, that we would sell, but our product would actually be steam, air, and water that we send into the different end users on the areas. That way, if they didn't get the proper quality steam, compressed air, they couldn't make their product. So if we do our end on our part there to make sure we have a quality product going out, we can make more pound of product at a cheaper rate instead of trying to put more energy into cleaning up and then getting a proper, say, quality of air and steam before we send it to them. That way it breaks that bickering back and forth about, just like Senator was talking about pointing fingers before, I mean, you got a lot of finger pointing going on between, production and maintenance issues, things like that. But, if we do our part, make our product to send to the end users, we'd be really doing a good job. So one thing is, and then if you notice, we have nitrogen up here. We concentrate on most of the items of plant air, instrument air, because that's our biggest users on the plant sites. But a lot of people kind of got the misconception that, nitrogen is just an inert gas. We don't use it for all that much stuff. We've used it for blanketed items and things, but nitrogen is an asphyxiant. It is very dangerous. The smallest leak can cause a big problem. So again, resorting back to safety items and issues, if we find anything to do with nitrogen leaks, it's a small part of our survey process as far as identifying. We find the leaks, but it's not the amount or the number of leaks that we find in nitrogen. It's the total quantity of CFM loss, especially if you're in confined spaces. So one of the things is that who's actually looking at these type of systems on your plant site? It's something to look back on and see that, we're making sure compressors are working, but what about the back end of it, Keeping the product in the pipe, that way we can save money and be very energy efficient as we go along. Compressed air leaks, artificial demand would increase the variable cost, by dollars per 1,000 cubic feet. It's typically between 90 and 95 or 94% of all compressed gas is lost, or the use of it is, again, instrument air and plant air. Primary costs, incremental increase, compressor drive and horsepower and energy. Other aspects is safety, health, and environmental. About if you're looking at one more click there. As far as the piping, the fitting material, the construction, any venting going on, is it venting in a safe place? We don't want to have a vent that's blowing off somewhere where people walking by. It's going to be very noisy. You don't have direct contact with any of that. Other aspects to consider would be the mechanical integrity, the condition of the piping. I mean, a lot of times we down south along the Gulf here, Gulf Coast regions, you have very corrosive environment with the salt spray coming off of the beaches. Some of our plant sites, have actually a very corrosive chemicals that they're using. So we want to make sure that the condition of the piping, you look at your valves, your valve packing, all your tubing fittings, and the reliability. Is it installed right? Make sure we put a lot of liquid drainers on the system to get rid of the moisture in the water, make sure they're working right. And we also look at the misapplication or the misuse of compressed air. A lot of times, they're using air to cool off an area or to blow out the shops, and you're looking at possibly 100 CFM of air that you're just blowing away, for a half hour or so, to where, we look at this and then we try to put into our report, to identify these different types of misapplications and, to help them lower their consumption rates and then get rid of artificial demand. I get a kick out of a lot of areas, you ask them about, they see something, we'll find something leaking, or they know it's been a leak. You can see a tag flapping around or something, and you ask them, how long it's been like that? And they say, well, it's been like that for the last 10 years. It really don't mean, it's been like that for 10 years, but it don't mean it's right. And I stress that on the steam side along with the compressed gas side. You know, we have a lot of turnover, mechanics and operators. A lot of times the training level drops off as you pass on, you know, each of the your little training sessions, or you go out in the field with the hands-on training and things like that. And, you know, one guy's telling the other guy, well, we got it set like this because that's how I was trained on it, you know, and the other guy tells the other guy that comes in, well, we keep it set like this, and then finally we get somebody that asks, well, why is it set like that? So then they got to go back to the older guys to find out what it is, and then we actually find out that the setting may be wrong, or nobody actually knew why it was done like that. So, you know, some of the things that we kind of dig into as we go along. And again, just because it's been like that don't mean it's right. It's just we got to make sure that we know why it's set up like that. In the process that we use, all areas on site are surveyed with the intrinsically safe device, which I personally use the UP2000. That's what I was trained on. It's an analog version. I'm sure a lot of y'all saw it next door with their setup that they have. It's an older version, but I mean, it works for me. It's intrinsically safe, so I don't have to worry about going into areas where I have to carry a meter, you know, explosibility meters along with it. That's what I'm comfortable with. We also use the 9000. We have some of them use the 10,000. The thing is, you know, you're out there in the field for 8-10 hours a day swinging a piece of equipment around, you know. It gets kind of heavy and tiresome after a while, so want to make sure that we use something that's versatile, that's lightweight enough for us to continue the surveys throughout the whole process, but also does the, you know, does the right job for us. The settings that we use on the 2000, I put mine on fixed band. On the 9000, we use 40 kilohertz, you know, was the basics on it. What I also do is we do what I call a baseline setting as we walk into the area. High noise area most of the time is the areas that we work in. So we adjust the sensitivity on it till we get down to right off of 0, so where we could actually hear something as we walk in. We don't want to make sure we go and over adjust it so we're missing out on things. Once the leaks are identified, we hang a yellow notification tag, and this is kind of the tag that we have here. I've been through several presentations where folks would talk about how they hang like a little ribbon or a metal tag with a number on it. These tags here are 2-part tags where there's a, you know, I don't know if y'all can see it or not. I have a couple samples with me over there. But it's a 2-part tag where I fill out the top part, give a description of type of leak, what area it's in, the date it's on. The bottom part, what we do is basically, it's almost like writing a work order on a leak itself. We have enough information on there that when we bring it back to the area, they take the bottom part of the tag and then start writing the work orders and stuff. We hang the top part at the point of the leak. That way when the mechanics go out to look for the leak, they can't say they couldn't find it by the description. All they got to do is look for the tag with the number on it, and they could actually find it. All leaks that are identified are written up on a spreadsheet. That's one thing I tell them is we talked about the baseline earlier. We don't write up every single leak. I would be at a plant site for probably 2 years trying to do that. So what we do is we try to identify anything above that baseline marking, what it would be worth us as far as maintenance folks to repair that leak. You know, we go out and we write up a leak that's only leaking like maybe a half a CFM, and the total cost of it might be $20, but it takes you $200 or $300 just to get a work order written into the system. So, you know, we have to draw a line of what we're going to do on that. So anything above that baseline, which we agree to set on, you know, with the folks that we're working with. And from there, I don't know how y'all have y'all reliability groups set up, or, you know, if y'all into these type surveys and all, but we have site energy champions, or is that person is responsible for anything associated with energy goes through them. They're the person that calls me to line up the survey. They're tracking energy costs, they're tracking, you know, utilities, anything associated with energy on that plant. Plus, you know, they're also doing DPS and lean and 50 million other things. So it's, you know, we kind of pull in a lot different ways. A lot of people wear a bunch of different hats, you know, and I'm sure everybody else is like that out in the regular industry. But either that or reliability engineer will be responsible for getting the notifications written or the work orders in SAP. And that's what DuPont is going to now as far as the maintenance system is SAP. So they'll get the notifications written in on there. And then from there, The spreadsheet, what we do is we send the defects out to each individual area where they verify the work orders that's written for the area. They break it out and they go through, put it on the schedule, get the job done. Once the repairs are made, what we do is we make sure that this yellow tag, the top part of that yellow tag, gets back to the planner who can close out the work order and then send it back to the site energy champion or the reliability engineer who is responsible for updating that spreadsheet. That way it closes the loop of the initial survey. So, you know, it's like, you know, we go out, we do a great job of getting the survey done. We see all these yellow tags hanging in the field and people want to know what's going on with that. You know, we had some instances where I was going through the area doing a survey, hanging tags, and they had a guy, you know, 20 feet behind me pulling the tags off because he didn't know what was going on. So, you know, communication is the biggest thing before you start surveys. And yeah, that was on my first survey. You know, I was just starting out, you know, and I said, okay, man, this is a great idea, and then forgot to tell the people in the areas what we were doing. So I want to make sure you communicate that to everybody to know what's going on. And here's the equipment that we use, or that I use personally. I mean, get a better close look at it. You can go right next door. Like I said, I use the 2000. It's easy for me. I'm very comfortable with it. You know, I also use a 9000. If mine breaks, so I have to ship it off. We have some regional offices that we have backup equipment that I could go to, or we could even call UE and they could send us some backup equipment, or like what Roy did for us is loan us some stuff for training and stuff. So, I mean, it's very versatile. You know, you could have the close scanning module or the contact probe, and you could probably do 80% of the work you need to do as far as any type of ultrasonic inspection, steam traps, bearings, you know, setting valves, checking for valve leakage. We also use the wobble tone generator on small heat exchangers for finding tube leaks. Works great. We had down in the Gulf Coast, they had a big heat exchange out and the guys were having trouble finding leaks on the tubes. I was happening to do a compressed gas survey through that area, and then asked some guys if mind if I get a shot at looking for the leaks, because they was only finding the big leaks. And then me and the guy that I was training went in a half hour, we found 20 tubes on a heat exchange that's probably 8 foot in diameter that was leaking by using this process. So very versatile. They didn't like us because we cut out their overtime on the deal. You know, we found everything, but you know, I thought it'd been a good training opportunity for the guy I was working with. So it all worked out. Again, it's very cost effective. You buy one piece of equipment, you could keep it under the $5,000 mark, and then it could do the job for 20 different pieces of equipment. Or what we try to stress is that it integrates very nicely with vibration monitoring and, you know, bearings and different things like that. So it's not taking the place of the other systems you have in place already at your plant sites. It's just helping to enhance it, because one thing I learned is that I guess I'm kind of hard-headed to where I need to see it and hear it to understand what's going on. So, you know, especially with the ultrasonics part and with bearings, we talked earlier about, you know, slow rolling bearings, things like that. You know, vibration might miss something, but if I'm listening to it, and you can set baselines with the ultrasonic gun, with the contact probe, and then once you see those numbers start going up, then you know you have an issue. But listening to it and hearing it right off the bat is the biggest thing. It's the biggest eye-opener I've seen. I get a kick out of watching the guys when I give them the headphones when I'm doing a survey and actually hear that leak or hear that defect. It's like, it blows them away. It's like, wow, you know, can't believe this. So here's another eye chart. I mean, and this is actually the process that we put in place, because I'm sure like every other companies that we have to have procedures in place, things like that. What we're doing now is using the airborne technology for our compressed gas leak surveys, and we're trying to implement the handheld data collectors to kind of speed up our process, you know, to automatically generate notifications, work orders. But this is basically like a best practice of what we go through as far as starting a survey, and hopefully when the handouts come out, y'all could see this. But you know, it's the management process. You start the survey, you know, you pick your equipment, you go out, and it's basically like what we went through on slide 9 previously. You know, you find a leak, you identify it. What we try to do is a lot of leaks that we find out during the survey, if you carry a channel ox and a crescent wrench or a 9/16 combination wrench, you could probably fix 75% of the leaks you're gonna find. because it's the little tubing fittings that constantly leak. You pull out an automatic valve, you change a regulator, whatever. You know, you got 2 or 3 guys working together. One guy puts it in, hand tighten, and walk away thinking his buddy behind him is going to tighten it up. Then he gets something else he has to do. So a lot of times we can just walk through, tighten it up, and move on. And that's when we can actually say, you know, we actually have a savings at that point. You know, we do the potential cost avoidance survey report that, you know, if you fix all these leaks, you can save $1 million. But, you know, we got 1,500 tubing fittings that's leaking, and then you could probably shut down 2 compressors, but nobody's fixing these leaks. So, you know, we try to put that into the report, and that goes through the process of, you know, we don't want to be robots to follow every process, you know, step by step by step. Again, you have to have the common sense with the proper training to not only follow the procedure, but get the job done, get it done in a timely manner, and making sure you're doing a professional job at it. And as you're going to note later on in the presentation, the steam trap process is we kind of copied off of this. And that way we made it similar. That way, you know, people that's doing steam traps might be doing compressed gas leaks, same equipment, same training, things like that. This is a feedback from last year, the surveys that I did. Conducted 5 plant surveys. The results, 2,600 CFM compressed gas leaks identified, $312,000 total loss in savings, or, you know, potential savings. $270,000 of that was just compressed gas leaks, which was instrument air, compressed air, right? Equivalent to about a 600 horsepower compressor. So that was just at 5 different sites with these surveys, you know, and people are not realizing how much air we're wasting. They can't figure out why they always got rental compressors on plant when they got 3 compressors running already. And then, you know, a lot of them, when you mention artificial demand, they don't think of leaks, but, you know, artificial demand, not only the leaks, but the misuse of the compressed air. Here's a breakdown of the types of compressed gases that we survey and the results from it just from 2012. You know, you're looking at $63,000 just with plant air losses, $200,000 instrument air, you know, $11,000 on breathing air, $28,000 on nitrogen, and $10,000 with the different, you know, natural gas, argon, oxygen, things like that. All the surveys I've done, you know, starting in 2006, because I got level 1 certified in 2005. Thanks, Drew, if he's in here. We've done 59 surveys. As you can see, it's been quite busy, traveling a lot doing this. We had about 29,000 cubic feet a minute in compressed gas losses. That's almost $4.7 million in potential savings during these 59 surveys. 3 million of that just in instrument air, compressed air. And you can see that, you know, 26,000 CFM. The plant air, you know, almost 1.3 million. Instrument air, almost $1.5 million. Breathing air, 233,000. Nitrogen, you know, 1.4 million. And others, you know, $166,000. Again, you know, we showing these numbers here. Means a lot to me, means a lot to management, but the guys out in the field, operators, mechanics, you know, not their fault because they never were trained about it. They really didn't know, you know, the actual process of what goes on and actually how much, you know, these different type gases cost. But again, you know, everybody takes for granted that compressed air is free. Power sends it to us, we use it, we waste it, we don't care. But, you know, in the long run, that site energy champion or the reliability engineer is the one really looking at it saying, like, how can we reduce our costs? You know, how can we, you know, increase our profits? How can we run our plants safely? It's all part of these surveys that we do. Since it's right before lunch, I figured we'd put some pie charts in there to get everybody ready for as you can see, instrument air, plant air is the biggest piece of the pie. A lot of times when I go to plant sites, they stress that we just want to do plant air, you know, survey. We don't want to do nothing else, just plant air. Well, you know, you got thousands of feet of pipe, sometimes, you know, miles and miles of piping on a plant. Usually headers are run side by side, plant air, instrument air, breathing air, nitrogen, it's all there. So while you're surveying, why not survey everything? You know, it takes the same amount of time. It may take just a little bit longer to hang a few more leak tags or whatever. But a lot of times, they have a project come up and say, hey, we got issues with nitrogen, so we just want to do a nitrogen survey. That, I could see just doing that by itself because, nitrogen is a high-cost compressed gas. You have safety issues, along with it. So, you would do that part. But usually what I convince them to do is let's just do a site survey on all your compressed gases. That way you got a big picture of what you're dealing with, then you know what to go after, as far as cost-wise. And again, in cost here, you're looking at over $3 million, since 2006 of what we lost. Some of the observations or defects that we find with compressed gas and plant air and instrument air, these quick connect hose fittings, that's great for hairing up, plugging in, popping out, changing impact, stuff like that. The little O-ring inside of it, starts to dry rot and starts leaking. They'll leave the impact energized, 3 days before the shutdown. They're using it the whole time, and then a week after the shutdown, it's still energized, leaking. Nobody really seems to realize that, you're losing probably 50, 60 CFM of that fitting blowing through. So when I go by, I try to get the guys to valve it out or to try to repair the O-rings, leaks in piping, pipe threads. That's one of the biggest culprits we find. The lack of proper pipe sealant. A lot of times they'll put a pipe lubricant on it thinking they're sealing it, but you have to use a pipe sealant to make sure that you're going to stop that leak. And valve packing. I mean, things get corroded over the years or just by the valve being open and closed, a lot of the packing wears, we find a lot of that. On instrument air, the regulators that we use to drop pressure before automatic valves and stuff, the diaphragms start leaking on them. A lot of people pass by and you can walk by one of these regulators and you see the coverall pants legs just flapping, it's like, well, where that's coming from. The weep holes on the regulators are leaking. People, well, it's supposed to be like that, We went to some manufacturers and they actually told us that normal leak rate would maybe be a half a CFM. We're picking up 4 and 5 CFM leak rates on these regulators. So if you see something out there like that or you hear them, most of the times you're not going to hear these leaks unless you're using ultrasonic equipment. But some of them are big enough where you can feel and hear and identify it right off the bat. One little trick that, well, not say a trick, but something that I tell them is if you see something that's been leaking a long time, it leaves a dust trail on either against a wall or on the tubing itself. You see like a grayish or blackish like little fan trail off of the leak. And if you go check that, you end up finding a leak there. So if you're just doing visual inspections through your areas and you see these little dust buildups on fittings or if you got a regulator blowing against a wall, you see these little trails on there. Again, you got your tubing fittings, loose fittings, valve actuators. Breathing air, again, threaded fitting connections, union leaks. A lot of the little can filters that we use for filtering out some particles and stuff, the O-rings will leak on there. Nitrogen, have some leaks on piping, solenoid valves. I mean, that's a killer for us most of the time is either the solenoid or the solenoid block is leaking. The filter housing drains. And in natural gas, we'll pick up, very hard to pick up a lot of natural gas leaks. They do make some infrared meters now that actually show the leak itself, but using ultrasonics, we'll find valve packing leaks or again, some solenoid valves. You can smell it, but half the time you can't figure out where it's coming from. You really have to take your time with it. One thing that I learned the hard way after I wrote up a couple holes in pipings and then realized it wasn't a hole in the pipe, it was the actual flow going through the piping itself. So, and that's one thing as with experience comes. It's kind of hard to teach that right off the bat, but with experience of listening to compressed gas systems, when you're around inline regulators, reducing stations, things like that, the velocity of the gas going through the pipe will create an ultrasonic disturbance inside the pipe. So you have to pick up that higher frequency on there. And if you could be scanning the side of the pipe and swear that that's where the leak is at, but it's actually just the noise inside the pipe. So that's something to remember when you get onto that point. Some of our observations, most compressed gas defects are easily identified and corrected by routine ultrasonic leak detection surveys. And we can't stress enough about, our surveyors or the folks doing it being trained. If we're not trained, we can't do a good survey. We don't turn over a good quality product. We want to make sure, again, the big misconception out there is I go to a plant site, high noise area, you're not going to find nothing because it's too noisy. You try to explain to them with the equipment that we use, the headphones, it blocks out all the noise. We could set the sensitivity on the machine to block out all background noises. And we could find some of the smallest leaks on instruments in very high noise areas. So, that's something that, if somebody tells you that you can't find it because it's high noise area, we use the equipment correctly and then we could find it. About 90% of compressed gas loss is, again, plant air, instrument air. Nitrogen leaks only account for about 9% of leaks that we find within the plant sites, but represent about 31% of the savings. I'm sure at all of y'all sites, sometimes nitrogen could cost, $4, $5, $6 per thousand cubic foot. Some sites, nitrogen may be free. Sometimes it's they say byproduct or something, so they'll just 1 or 2 cents per thousand cubic feet. But most of the time, nitrogen very expensive. The work that involves removal of instruments, tubing, piping, must be re-energized when the system, when we finish the repairs. What we try to stress there is they have the smaller, ultrasonic UP100, which I consider like a toolbox instrument where you could keep it in a pouch or bag, and when the I&E guys or the instrument guys go through and repair, change a regulator, swap out automatic valve or whatever, they could go through and double check at that point that the leak had stopped. That way we didn't create any new leaks by changing the equipment. They're going to wear, so it must be checked on a routine frequency. What we try to do is we try to survey the plant sites at least once a year if they're going to implement a compressed gas leak survey program. If I'm doing it, we kind of tell them that if they don't repair at least 75% of the leaks within a certain amount of time, we're not going to come back the following year to do a survey, because all we're doing is just be hanging leak tags on top of leak tags because the work hadn't been done. So we try to, we give them an incentive that, they're not going to have to pay for a survey as far as, getting me in to do it over. But if they come back and say after 6 months they complete at least 75% of their leaks, then we'll go back in and resurvey, just to check up and see how they did. Then from there, we try to get them trained to go ahead and start doing the surveys themselves. We'll also look at the defects of the misapplication and misuse of compressed air and the lack of awareness. And one thing we got to remember, folks, is compressed air is not free. That's, again, big misconception. Everybody thinks that, air is free, so we can just waste it like we want, but, we're not going to do that. Now I'm going to turn the presentation over to our steam systems. Again, using the same type equipment. From there, we look at how DuPont plants and any plant in general, industry all over, just think of it as, we're talking about your plant site here. Quite extensive. You got your generation facilities, you got thousands and thousands of feet of running pipe, hundreds of thousands of steam traps in your systems. From there, you have a diverse mix of traps and applications, and with the utility and process areas. In addition to the steam loss or other energy-related items associated with the surveys, we look to improve the steam trap and condensate leaks. We look at what we put together as best practices for different things. Steam traps and associated steam piping, condensate. If you look at steam traps, the functionality of them, they're going to fail open or they're going to fail close. There are subsets in between, what we consider as rapid cycle, leaking, or full blow through. When we go to calculate loss on failed open steam traps, we have factors built into, where the surveyor determines if it's either failed open, leaking, or rapid cycling. We don't use 100% blow through on it. We try to break it down to where if it's leaking, we might only be losing 10% of what is possible leaking through that orifice size. If it's a full blow through, it might only be, say, 80%. We get some surveyors to come in, third-party surveyors, and everything is failed open, 100% blow through. Sometimes you got to watch because the report says we saving more steam than we're actually generating. So, that's kind of impossible to do that. And I'm still working on that concept. If I could figure that out, I'll get it patented, and then next year I'll be talking to y'all about how to do that. We want to visually examine the, not just testing the steam trap itself. We're looking at the piping, the insulation, the applications. We try to look at the entire system. Additional energy-related items, opportunities to reuse condensate. Condensate, you have to look at it, it's water that's already treated and it's already hot. So we want to try to get that back to the power system to reuse that, get that latent heat out of the condensate. If we just dumping it and have to use more makeup water, that's cold water coming in, we have to add more chemicals to it, so our cost of steam just jumped up. So if we could return as much condensate as possible, that's the goal we want to look at. Then we want to try to utilize that condensate. You could put it in flash tanks, flash it off at a lower pressure steam, and use that for smaller applications. Opportunity to return to misapplication or poor utilization of steam. We try to look at, why do we have problems? We can't return condensate. You can't put a low pressure steam into a high pressure condensate return. It's not just going to work. So we try to look at those misapplications and all. Our surveys provide the opportunity to identify and assess potential safety, mechanical integrity, and design issues. For safety, health, environmental, we look at water hammer. And that's something I get a kick out of also is, I could be a comedian at times when it comes to some of these things, but you walk into an area and you hear banging going on and nobody seems to be concerned about it, and you ask them, well, what that is, and it's like, oh, that pipe been doing that forever, ever since I've been here. But they don't realize that it's water hammer and something in the steam system is causing that water hammer. So I take that very seriously. I've been at plant sites and been through incidents where we had water hammer that caused equipment failure. I've seen 10-inch valves blow out the side. I've seen 2 operators get sprayed by 25-pound steam condensate when a strainer busted open on starting up a header and it was on a scaffold. They got burned, plus they jumped off the scaffold and broke ankles and broke legs. I mean, that's things that we can prevent by actually doing, a good job of doing a complete survey instead of not just worrying about the traps. We have to look at the entire system. You also have to look at leaks or where we're venting at, if you have an air vent on a heat exchange, you want to make sure you vent that off to a safe location. You don't want to have it venting off eye level when somebody passes by, it hits them right in the face. And we're looking at the material and the condition of the insulation, how much bare piping we have out there, all things that could lead to water hammer. System discharge points, flash steam, thermal burns. We have sites up north, just like everybody else, where they're dumping condensate to the ground. It starts to freeze. You get a big ice skating ring out there, and when you walk on it, you slip. You have slip, trips, and falls. Of course, here down south, we probably freeze once every 10 years, so we kind of take for granted that we're not going to have these issues, but when it does happen, we have to be prepared for it. And then also have erosion, corrosion from steam leaks. On the mechanical integrity side, you have to be looking at your piping, your fitting corrosion, and actually erosion and corrosion from leaks on adjacent piping that something's leaking, dropping down on, it's going to start to rust. It's going to start to affect the integrity of the pipe, and then you end up with a leak or a blowout there. And if you have contact points of like pipe hangers or different things that's actually touching the pipe itself, you could have friction wear, and it could be wearing out leaks on there. And design will make sure that adequate system or component isolation valves, that they're actually working properly, that you could actually shut them off for complete shut off and all. And high point and low point vents and drains if you have to drain your system. Steam loss from leaks, it adds artificial demand to the steam system, and there's opportunity to effectively utilize the return of condensate, and we're looking at pounds per hour coming back to the boilers. Again, safety, impact, incremental emissions of water, use of chemical treatment, again, piping fittings, everything that's going into this as steam leaks is going to eventually come out to some type of incident, burn, slip. And then the main thing also is noise. I don't know if you ever tried to blow down a 550-pound steam header off the main header. If you don't have double hearing protection, and you definitely don't want to blow it straight down, because once it hits the ground, it's splattering all over, and you're looking at, almost 500 Fahrenheit condensate splashing all over. Not only are you going to have the steam and the noise, you're going to have the condensate flashing again, so a big cloud, nobody will see. You could be stuck there and you could have a serious burn from that. But noise itself is, we walk by, and if we have something venting or leaking, that's one of the first things we try to do is contain the noise. We try to clamp it or shut it down and try to get it repaired. And again, mechanical integrity of the piping, the fittings, the packing. If a steam valve's been in service for 20 years, you're probably not going to be able to tighten the packing gland on it. You'll probably pop the eye bolts off, or it'll just be blowing through so much. So, from there you have to write it up, shut down item, or you have to call in these leak repair groups that can pump them up for you. And reliability, again, as we mentioned, all your isolation valves actually going to function properly. Process that we use, again, similar to the compressed gas survey process. We try to utilize 3 test methods when we're doing steam traps. We use sight, sound, and temperature. What I use here on that is, as far as the visual of it, I have an infrared camera, little small handheld. You could take a picture with it. You could just do a quick scan, make sure your hot inlet and exit the trap. You can see if the trap's functioning or not. Then I use ultrasonic test equipment. I'm listening to the trap the whole time. I'm taking my temperature readings. That way I can listen through the cycles that the trap goes through. Main thing is, what we have to remember is, there's different type traps, different type technology of traps, so they're going to operate differently, for different applications. So we have to make sure we know our steam systems, our process applications, plus the steam traps. And again, we use the 2000 intrinsically safe. Once the trap is found to be defective, either failed open or failed close, I have another tag that we use as a red trap leak tag, which again, we can identify the trap number, the date it was found, and if it was failed open, failed close, or whatever. We hang that on the trap. That way, again, the mechanic coming in to do the repairs can go ahead and find the trap and make the repairs from it. Again, we write them up on a certain spreadsheet that we have. That spreadsheet, once we input the data on it, it'll calculate steam loss, steam cost, failure rate. It keeps track of how many traps are in service, how many are out of service. That way we can not only do reports on traps that are failed open or closed, but all the traps that are out of service. I think we miss that a lot, as far as a trap supposed to be a winter-only trap. It's supposed to be a critical tracer trap. If we keep testing this out of service, we have to, what I do is I print out a list of all my out of service traps, and I hand that over to the production superintendent or operations, and I have them go and track out all of these traps to find out why they're actually out of service. And if they deem that they should be, then we will tag them with a special tag that it's either a winter-only trap or seasonal or process application type things. Again, site energy champion, reliability engineer, they in the loop on both surveys, so they'll get the same information, and they're basically doing the same thing as the compressed gas stuff, but they're just writing up steam traps. And then after that, the area is responsible for making the repairs. What we try to do is put a time frame on repairs to be made. Like, we prioritize by the biggest steam loss or the biggest hazard or process application, and we try to get it to have the traps repaired within 2 to 3 weeks once the work order has been ready to schedule. So that way it gives them time to get the parts in, get the jobs kitted, and then have maintenance go out and do the repairs. Once the repairs are made, the little red tag come floating back in again to the reliability engineer or the site energy champion. He takes that with the trap number, verifies it on the survey spreadsheet, and again, changes the status to repaired, and that closes the loop again on that survey. Same thing as we went through in compressed gas in 2012. I did 14 trap surveys. And when I do a steam trap survey, it's not just looking at steam traps itself. I'm looking at steam leaks, I'm looking at process applications, I'm looking at the integrity of the insulation, things like that. So, you know, I got a little spreadsheet with little bitty columns on it, but you got to learn to write real small to get all that information in there. But we try to do as best we can to identify a bunch of different items on there. But what we found in the 14 steam trap surveys and 232 million pounds per year, or 26,000 pounds per hour steam loss, and that's with failed traps. That was like about $1.4 million of cost avoidance or steam loss that we had last year. The trap failure, the failure rate, you see here there's two different failure rates. That 14.43% is our actual failure rate average among 14 sites. This 9.6 is kind of misleading, and what we've done is we found that through several third-party contractors that's done surveys at our sites, some of them would calculate the failure rate as all the traps on the site. So if I had 6,000 traps, but 3,000 of them were out of service, they did the total failure rate with the total 6,000, not taking out the out of service and cold traps. So what we do as a DuPont standard is that we take out any trap that's out of service or what they deem as cold, and we do take that out, and only the traps that are actually in service and operating is what we use against the traps that were failed. And then that gives us a more accurate failure rate of what we have to go after, you know, because anything looks good and sound, you know, looks good on paper, but if, you know, you have to back it up with actual facts of what we're doing. So we try to make sure that we get the actual traps that's in service and operating to get our failure rate. The identified steam loss for steam leaks itself was about 105 million pounds per year, or 12,000 pounds per hour. Cost us about $641,000 per year. And what we have to look at too is our CO2 emissions, because I mean everything is set. You have certain amount of emission limits that you have to worry about and all. So we ended up with about almost 6,000 tons per year of CO2 emissions. And water loss for anything like trap discharge in the atmosphere or external steam leaks, you're looking at over 11 million gallons a year of water. And total steam loss, if you're looking at it, what we had in 2012, we could have purchased a 1,200 horsepower boiler. So that's a lot of steam that we lost, you know, and that's just 14 surveys last year. Next chart is what we've done since 2006. We've done 59 surveys, identified almost 1 billion pounds or 16,000 pounds per hour steam loss at $6.5 million in steam trap leaks alone. And percent failure rate, again, we're averaging about 14% across the board for our sites. Now granted, we have some sites that's doing excellent with 2% per year failure rates. We got some sites that, you know, 14, 15, 20%. We did a little short survey amongst industrial average, and it's usually about between 20 and 25% of failure rate of industrial plant sites, especially if they don't have any type of routine trap maintenance program. As far as steam leaks, 523 million pounds, 8,500 pounds per hour, almost $4 million just wasted in steam leaks, 34 tons of CO2 emissions, and almost 70 million gallons of water that were just wasted from our leaks. Again, our pie chart shows, you know, steam traps are going to be our biggest wasters as far as steam waste and all, but sometimes we do come across quite a few large steam leaks. Again, with the steam leaks itself, you're going to have noise issues. You're going to have safety issues for thermal burns. You're going to have hot condensate spraying around. So you have to watch on all these. Some of the observations and defects, steam traps will and do fail. And when they fail, there's two different modes they're going to fail, either failed open, failed closed. Again, you have a full blow through, rapid cycle, or leaking. It increases the steam use or the loss of live steam. Your process key performance indicators, or KPI, which is your BTU per pound, increases. When you start getting these increases, then your cost for your product starts going up, profit goes down. We end up overpressuring condensate return systems, which can cause a whole other headache on different processes at lower pressures. Cause water hammer, which is very dangerous. So again, if you go back to your plant sites and you hear these noises of banging on the headers, that's not normal. Please look into it. Then you have improper heat transfer or inability to maintain your throughput for your heat on your process applications. Because once a trap starts blowing through, even though it's live steam blowing, the temperature actually drops some because we're not backing up, holding up that latent heat, so then we're going to lose some temperature on it. Failed closed trap, it's not losing live steam, which some people think is great, but you have to look at it on the side that we're backing up condensate. It's going to back up into the headers. It's going to be poor steam quality because you can start having wet steam going to your units. And a lot of the processes that we have, that we can't allow wet steam to either hit the process direct contact, or we need the dry steam to go through it, and the saturated steam. We don't want wet steam. You have no or poor heat transfer, because if it's failed closed, you end up having your condensate header side hotter than what your process side actually is. You're going to start flooding heat exchangers. Once you start flooding heat exchangers or headers, that condensate is going to start forming carbonic acid. And then you'll be looking at mechanical integrity issues with holes in piping, or it's going to start leaching out the carbon inside the pipe, and then that'll start transferring down through the equipment, into the steam traps, or it'll start plugging things up and just looking for more and more mess. Trap failures represent 65% of total steam loss and roughly about 62% of our energy costs. Some of the observations and defects, again, is the steam leaks represent about 35% of our steam costs, roughly 35% steam loss, 38% of energy costs. And again, leaks from piping and fittings, packing glands. I mean, you go out there, if you know your steam system, you know what's going to be leaking. Some observations, most steam trap and steam leak defects can easily be identified and corrected by routine ultrasonic leak detection. Again, the surveyors must be trained. When we're talking about training a surveyor, we want to make sure he's trained on the equipment that he's used and then the process and the applications of what he's looking at. I mean, we just don't want to give the piece of equipment to somebody and tell them, here, go do it, figure it out on your own, which unfortunately we have that happen quite a few times. But if we could train the surveyors and the people that's going to be doing the work, we'll get a better quality product on the end. Same thing with the maintenance personnel that's going to be changing out the traps. All too often I get a call that this brand new trap is not working, it's blowing through or whatever, and you go out there, it's installed upside down or backwards or whatever. The mechanics need to be trained on the proper installation of steam traps, because most of the traps are position sensitive, and if they're not installed in the correct way, they're not going to operate properly. 9 out of 10 times it's not the mechanic's fault that he put it in wrong. He was just never trained or told on how the traps should be installed. So that's what we have to watch. Applying ultrasonic leak detection in areas where components are difficult to access. We can get extension probes that we can put on there. We don't have to climb ladders or get on scaffolds, things like that. Misapplication and a misuse of steam. Again, a lack of awareness on it or complacency. You need a steam tracing line to warm up something. You're going to take it off of a strainer of a steam trap, where it's not the best thing to do, because you're pulling off all your trash and your condensate, going to that tracer line, and you end up plugging up what you're trying to heat up. And here's the mugshot I was talking about. The training that we do, again, the training I got from UE Systems was invaluable. I mean, if you ever got the opportunity to go through there and do their 1 or 2 day class, even the level 1 certification. I mean, they throw a lot of information there, and it's just overwhelming at what you can pick up and bring back on it. What I've done was I put together a 2-day training class for our DuPont people. And basically what we do is we try to get in mechanics, operators, engineers. We try to get in some managers. That way they know what we're trying to do and the service we're trying to provide. It's a 2-day class. First day is on ultrasonic leak detection. We show them how to use the ultra probes. We usually have a 2,000 or 9,000 in class. That's the 2 basic ones that we have. Some of them come in and they want to show off their 10,000. They put it on the table, and that's great. I mean, but we use the 10,000 for more of condition monitoring on bearings, things like that. When we're doing compressed gas and steam traps, we use the 9,000 or the 2,000. Again, we show them how to use the equipment, how to be comfortable with it, what to expect when we get out there. That's the first half of the day is like classroom training. Second half, we go out in the fields as a hands-on. We give them the instrument. I have a splitter to where I'm plugging in and out of different guys that's doing the surveys. And again, I need to start bringing a video camera just to video the faces of the guys when they find these leaks. I mean, it's just overwhelming that they're walking by and all of a sudden, man, what is that, And it's, high noise area, they all there complaining, you ain't gonna hear nothing, blah, blah, blah. And then next thing you know is, hey man, listen to this. So everybody's, plugging in their headphones and stuff. So it's really amazing. So after they're all excited about that, we come back the next day and we do steam traps. Basically the same thing. We'll go over trap operation, process applications, how to test the traps. We have some little videos on, they can see how the traps operate, get a better understanding of what they're looking for. Then we go out in the field and we do a mini survey, and they listen to the traps, they take the temperature readings, and I get them to explain to me what they're hearing. And that's one thing that they tease me about, but sound effects. I mean, I got the sound effects down for different traps that, a guy will call me up and say, man, I got the problem with this trap. I'll say, well, what it sounds like? Well, I don't know. So I'll do a sound effect for him, and yeah, that's it. I say, oh, the trap's blowing through or it's leaking, So we joke about that, but when they see the little videos of actually hearing it discharge the atmosphere, but then using the ultrasonics while you're listening to it, then the little light bulb goes off saying that, this is what I'm supposed to be hearing. So we do that. We go over some electrical stuff with corona tracking, arcing. I don't have electrical background, so we don't dwell into that too much, but a lot of times I got some electrical guys that's in the class that we kind of go on the side and talk about that. We do talk about bearings, using with lubrication and the different equipment that we have, that UE has for their bearings and stuff like that. And a lot of sites that we have their own lube program on site has a lot of these, and they say ultrasonics is overwhelming, especially when you're greasing the bearing. I was talking with somebody about that last night. A lot of sites have standards that you come to a grease route, pump 5 shots of grease into every bearing that you see, So they're going out there and they got piles of grease this high out there and wonder why they're having failures. Well, we got grease in it, but listening to it, when the bearing settles out, that's when you got enough grease in it. So even if procedure tells you 5 shots of grease, if I'm doing a second shot and then it starts to level out, that's how much grease you want to put in it, then you walk away. A lot of guys, they save a ton of money on grease by doing it that way. So that's another cost savings that you can put into it. But again, this is what we offer within DuPont. We've done it a couple times with some of our folks that we help out as far as customers and all. And what we've done, we've had 19 sessions of compressed gas and steam traps. Again, it's a 2-day class, and what we do is we try to set it up at a regional site where we can bring other DuPont sites in, within an hour maybe, that they could drive in and then drive back out. We've had, almost 180 participants from 33 plant sites. And, to me, it's invaluable training for them. It gets them started on the process of how things work and all. And we also have allied equipment training that You know, we get UE systems to come in, train. We get steam trap vendors to come to the plant site. You know, we get people for vibration monitoring, bearings. You know, we try to incorporate all of this type of training that they have after what we call our 2-day short course. We try to push the guys that's going to do the surveys to get as much training as they can. You know, we're not telling them that they got to get certified up to level 3 or nothing like that, but I mean, just having the actual training and the hands-on experience with the equipment is the biggest plus that we can have, you know, within our plant sites. And again, that's just kind of gives you a flavor of, you know, we don't just train operators or mechanics. We try to get everybody on site involved in it. That way, when somebody says, you know, we got a steam trap survey coming up, they kind of know what to expect. And then, you know, they can see people out there walking around with headphones or waving something, you know, trying to figure out what that is. That's just, you know, us doing our jobs. And some final thoughts, you know, with the expanded presence worldwide, DuPont sites must include ultrasonics within our maintenance technology toolbox. Again, it's a piece of equipment that to me is inexpensive and it pays for itself after the first survey. You know, a lot of people don't believe that, but if you're using the spreadsheets to track your loss and your cost avoidances, and probably after the first day you use it, you done paid for it 2 or 3 times over. So what we try to stress is that, you know, some sites say that, well, we don't have the manpower to do these surveys. You know, we don't have the money to get outside contractors to come in to do that. Well, if you look on there and you see how much money you can save out of doing, you know, just a 1-day survey, you know, if you do an entire site survey, it might take you a week, 2 weeks, or whatever it is. You can actually pay for 1 or 2 people full time, you know, just for doing those type surveys. So you can have one guy assigned once a month to do a certain area at the plant site, you know, either steam traps or compressed gas, and give him that 1 week out of that month to do that survey. Let him put the little report out, get the repairs done. Next month you come over again, let them do a different area. You know, keep the equipment in their hands as often as possible so they could keep the technology and the experience and the training. That way, if they get it in January and don't get it again till December, what you're doing, you done forgot everything you learned. You got to go back to the book or whatever. So if you keep the equipment in your hand as much as possible, use it as much as possible, and, you know, nobody's perfect. We're going to make mistakes. You know, as the Senator said earlier, you got to learn from your mistakes. Some of us just take longer to learn than others, you know. I've been there, done that. But, you know, like you said, you know, we're going to mess up. We're not 100% perfect. There's no equipment out there. There's no self-diagnostic equipment that you could use that's going to be 100% perfect. You know, we got some sites that want to use these self-diagnostic steam trap testers. That's fine. Make sure the person that's using them knows steam traps, knows your steam properties, your process applications. That way that when the machine tells him if it's good or bad, he can actually verify that or change that. We don't want to take the human aspect out of surveying and stuff. So we just want to make sure that we can go through and do a proper survey. Some of the smaller sites, we try to do a lot of network and training, leveraging with tools and personnel. You know, we have regional and global networks. We try to do some webinars, face-to-face trainings, and we do have some computer-based trainings that we put into the plant sites and little 15, 20-minute gig on, you know, different surveys and stuff that we do. And that's it.